So the last main chapter we studied was chemical reactions. Yeah? Okay, going from reactants to products. And the way that that has to happen, right? When we have a chemical reaction that goes from reactants to products, there's got to be some form of energy change. Okay, and there's an energy transfer that happens. Okay, in all sorts of chemical reactions. Energy is really like the basis of all of the sciences that we study. And how energy is consumed, how it is transferred, how it's transformed. That's all about science, right? Energy is all at the base of kind of really all of our sciences, okay? So chemical reactions include an transfer of energy. In order for a compound to break down and reform into something new, energy has to be put in to break the bonds of that compound. Okay, if we have a carbon and two oxygens bonded together, we've got to put energy in to break those bonds so that now we have an oxygen, a carbon, and an oxygen so that they can rebond to form something new. Okay, so energy is kind of where we're moving into next. We're going to talk about all different forms of energy, all different types of energy, not just energy in chemical reactions. We're going to kind of go all the way through this. So now we're shifting a little bit more into like the physics side of our physical science class, right? We did a lot with introduction to chemistry stuff, and now we're doing more on the like physics side of it. Okay, so now we're kind of getting into that. But we're going to look at all the different types of energy, right? We can hear energy in sounds. Okay, sound travels through waves, and energy travels in that wave. We see energy as light. You can feel it as wind. What other types of energy do we have? Give me some types of energy. Water. Okay, water's not a type of energy, but it might carry energy. Okay, how would water show energy? How would we see energy in water? Movement. Yeah, that's right. Any sort of waves or movement. Okay. What other types of basic energy do we have? Okay, yep, chemical energy within our bodies. Yep.
Heat energy?
That's right. Heat energy, light energy, electrical energy, right? All of these different things are considered a type of energy, okay? So it's all around us. We can hear it everywhere, see it everywhere, feel it everywhere, but it's all around us, okay? All right, we use energy and with all the different types of things that we do. Anything we do with our body, it involves an energy transfer. Okay, it involves an energy transfer. So how does our body gain energy? Food, right? Food is what our body converts into chemical energy, right? So that our body can move. When we use that energy, we put it into something else. So the example of hitting a softball, right? I put in energy to move the bat. Then all the energy that's in that bat and in that swing is put into that softball to make it move, right? It's not going to, think about when a softball gets pitched at you, it's going one direction. And for it to be completely turned around and go the other direction, there's a big energy transfer that happens there. Agreed? Right? It doesn't just do that on its own. A softball is not going to go one way and on its own turn around. It's got to have an energy change. Okay, so everything that we do to lift something, to push something, to move something is an energy transfer. Okay, so I want you to see that kind of big picture concept. Okay. All right. Oops, I skipped one. All living organisms need energy for both growth and movement. Okay, so we said that the energy that we use comes from our food. Okay, think about way back in like elementary school. Where's everything stem from? The sun, right? The sun grows the plants, and the plants are eaten by the animals, and the animals are eaten by the humans, right? Everything in our energy kind of pyramid stems from the sun, okay? But it doesn't mean that the sun is our only form of energy, right? It helps things stem and help things grow, but it's not a form of energy, okay? Anytime we see all of these things happen, a bird, a bomb, rain, electricity, all of these different things are examples of energy, okay? I think that I hope that you're kind of seeing, it goes in, like the world is not random, right? God created this world to have very distinct patterns and things that we were able to discover, right? And energy is one of those things that's present everywhere. Okay, so it's not random. It's been created so that the world has these patterns and has these things that we're able to discover. Okay, so what is energy? Okay, how is it involved in so many things? right? I'm going to give you kind of a basic definition, and then I'm going to give you another one, okay? So work is basically energy is an object's ability to do work, okay? Energy is an object's ability to do work. So now, what question are you asking from that? What is work? There we go. Okay, so what do we think of when we say we're working? Yeah, we're doing something, right? Work can mean a lot of different things in the way we use that word. However, in physics, work has a very different definition. Okay, so I can be expending a lot of energy and feeling like I'm working really hard, right? I can feel like I'm working really, really hard. But the reality is that work has a different definition. Okay, so work happens if an object does work. This is kind of the definition here for work. Okay, it exerts a force over a distance to move an object. Okay, so if that happens, the object has done work. Okay, so let me break that down a little bit differently. So sorry. Okay. So you can also think about work as applying a force to move an object. That maybe is a little more clear, concise definition. Bless you. Okay, so work is applying a force to move an object. That's really important. Okay, the object has to move in order for us to be considered doing a work. Okay, so let's go back to very, very basic definition of what a force is. I want to see if anyone knows what a force is. We haven't covered this, but I want you to kind of know what would a force be. Any ideas? A force is any sort of push or pull on an object. Okay. So if I am pulling up on this desk, I'm applying a force. If I push on the desk, I'm applying a force. Every time that I'm just standing here, gravity's applying a force on me. Right? Otherwise, I would be floating. Okay? Without the gravitational force between me and the earth, we'd be floating. Okay? So there's forces all over, but forces are a push or a pull. Okay? So if I'm doing work, that means I'm pushing or pulling something to get it to move. The important part is that it moves. So I can push on this wall all day long, and it might feel like I'm working really, really, really hard, but am I doing any work? No, because the wall's not going to move, right? So in order for it to do work, we have to see movement there, okay? So now let's work a step back. Energy says I have the ability to do work, okay? So just by me attempting to do work, that means I'm expending energy. Okay, and so you have lots of different types of energy, but you have to have the ability to do something. Okay, so any object that does work uses energy. That's what we just said. If you are doing work, or even if you're trying to do work, you're expending energy. All right. Because energy and work are so closely related, they use the same unit to measure them. Okay, the unit for both energy and work is called joules. Joules. Tell me again what a unit is. What's a unit? Bingo, the label of the measurement. Okay, so we might say we do 50 joules worth of work, or this object has 100 joules of energy. It's just like saying this table is 1 meter long, right? Or she is 2 meters tall, or whatever it might be, okay? It's just the same, the unit that goes on the end, the label. Okay, objects can use both work and energy. They can use both energy and they can gain energy. We're going to talk about what that means, okay? How objects can gain energy, how they can lose energy, okay? If we're using energy, it means that our object does work on something else, okay? So I apply a force to move something. That could be just me walking. That could be lifting something, pushing something, all that kind of stuff. How do I gain energy? What did you say?
A person?
Yeah.
Like, how did it through sleep and eating?
Okay, that's one thing, right? As a human, that's how we do it. But how would an object gain energy?
Being transferred?
Yeah, bingo. Okay, if something does work on it, then it gains that energy. Just like the softball we were talking about, right? If the bat hits the ball, that ball has gained all the energy from that bat, right? And now it's moving forward. Does that kind of make sense? That's called a transfer. We're going to look a lot more at that a little bit later, but that's called a transfer. Okay? So we're gonna kind of gloss over here 5 main forms of energy. We're going to talk about them just a little, not a whole lot. We're going to really focus on a couple things later here, but we're going to kind of gloss over the 5 main types of energy. Okay? First of which is heat energy. That is, I think, one of the most intuitive, right? Or the thing we really see the most. We feel heat. That's a direct feeling for us, right? And we can feel the lack of heat energy in something that's cold. Okay, so that's something that's really directly related to us. Chemical energy is what we use like in our body. It also has to deal with chemical reactions and chemical bonds, right? Those are the energy contained within those things. Electromagnetic energy. Okay, we see that all over as well. Nuclear energy. Does anyone have an idea what that might be? Nuclear energy is the energy found within the nucleus of an atom, right? Because what is found in the nucleus of an atom? Let's review a little bit back even further. In the nucleus of an atom, what 2 parts of an atom are in there? Protons and neutrons. And they're held together by really strong forces called nuclear forces. And so when those bonds are formed and broken, we see a lot of energy transfer there. Okay? And then our last type is called mechanical energy. That's really the energy of kind of movement and things like that. We're going to look at that a little bit more as well. Okay, so those are the 5 categories of them, and then we're going to dive in a little bit. Okay, so let's look at heat first. All right, heat energy. Okay, so it says the internal motion of atoms is called heat energy because moving particles produce heat. Okay, so when objects are in motion, right, we start to produce this heat energy. Heat energy is also produced by something called friction. Do you know what that term is? Have you heard that term before? Right? Friction happens when 2 surfaces are interacting. Okay? The more those 2... Take your hands and go like this. Do your hands get cold or warm?
Warm.
Yeah, they start... they kind of get warm, right? Those surfaces interacting are causing friction, right? Because those particles are moving together really, really quickly. Okay? Tell me about, in terms of friction, tell me some surfaces that have really high friction. What would be some surfaces, like just around your house or around wherever that have a high friction?
A stove.
No, not a stove. Think about things that you would touch. Carpet has really high friction. What else?
Polyester.
Depends. Yeah, could be. Things like wood, right? They have high friction. What are some things that have really low friction? Ice. What else? Glass. Good. Okay. All those types of things would be low friction. And especially if things are oiled, right? Think about like a bowling lane. What do they do to that bowling lane? Do you ever see that happen? Right? They grease the bowling lanes. Why would they do that? That's right. So your ball goes faster. Right? Your ball is not having friction along there, so it's able to flow more smoothly. So friction really does impact our world, right? I want to talk one more thing here about friction. What about friction on roads? What about friction between tires and road? Is it important for us? Yeah, it's really important. When does it become a problem? In what conditions, what road conditions do we have to worry about friction or lack of friction? When it's rainy, when it's icy, all those kinds of things reduce the friction between our tires and the road. So that's when it becomes a little bit more dangerous, right? So that all that kind of stuff plays in here. Okay. Heat energy changes in temperature and phase of any form of matter. Okay? It causes changes. So I want to think about all of the phase changes that we have. Okay, heat energy causes changes in temperature and phase in any form of matter. So I want to talk first about, just think about H2O. Okay, H2O is what? Water. Okay, so let's think about water in solid form. What is water in solid form?
Ice.
It's ice. Okay, so if I have ice, what is the temperature at which ice freezes? Where do we freeze? What temperature does water freeze at? Let's go Celsius. You remember what it is in Celsius?
Is it 20 degrees Celsius?
It is 0 degrees Celsius. It's 32 Fahrenheit, 0 degrees Celsius. Okay, so water turns to ice at 0 degrees Celsius. But let's say, what happens when it goes from ice to just liquid water? What has to happen for it to go from ice to liquid water in terms of like the temperature? It has to get hotter. Okay, so now I want you to think big picture here, or actually not big picture, actually really, really little picture. So I've got two water molecules that are frozen. Okay, they are bonded together. When they are frozen, that means our molecules move so little because it's so cold, they get stuck in place. That's essentially what happens, right? We're talking generally here, but our molecules have so little heat energy that they just get stuck. Okay? As we add heat energy, these molecules start moving and moving and moving and kind of almost vibrating. Okay? They start vibrating so much that the bond that holds one water molecule to another, right? The bonds that are holding those two water molecules together break, right? Because this is a water molecule, this is a water molecule. They're stuck together. Then they start heating up and they buzz back and forth, they vibrate, and then all of a sudden, boom, right? Now they're broken apart. And so now I've got two individual water molecules that flow with regular water, just like regular water, okay? They're hanging out, but they're not bonded, okay? So they're close together, and so that would be water. So heat has been added to make that happen. Now I've got two molecules that are in liquid form. What happens when I heat them up again? They become a gas. And do you know what that would be called for water? Water vapor or steam, right? Either way, right? But that happens at what temperature? 100 degrees Celsius. Okay, you see how the Celsius is much easier to remember? What's water boil at in Fahrenheit? Remember? 212. Right? Pretty random, right? But Celsius is built around water. So it freezes at 0 and it boils or it becomes gas form at 100 degrees. So in order for me to go to liquid to gas, the same thing happens. They put in heat. These molecules start vibrating and moving a bunch, and those bonds really break. And so now I've got individual water molecules floating around as steam or as gas, right? So they're completely broken apart. Does that part make sense? I want you to understand the process of going from solid to liquid to gas. That process is the same for any type of compound we're looking at, okay? But water is just really easy to see. All right, very good. Chemical energy is required to bond two atoms together. Okay, so it's got to be, we've got to add energy to help those bonds happen. And then when we break the bonds, we release energy. Okay, when we break the bonds, we release energy. Okay, the same thing is happening here when we're changing phases from solid to liquid to gas. So we'll see that happen in all of our chemical reactions, right? Sometimes you start a chemical reaction as a solid, it has to break itself down maybe to a liquid and then it can rebond or whatever it might be. But you'll see a lot of transformation happen going from reactants to products, okay? All right, fuel and food are also forms of chemical energy. They are considered forms of stored chemical energy. So I want you to think about what that word means. It's stored energy. Tell me what you think that might mean.
It's there, but it's not used.
Bingo, right? It's there, but we're not using it at this moment. We're not using it at this moment. Okay, so stored energy means literally just that. We are storing it away to be used later. Okay, that happens whenever we eat, right? Or whenever cars, have fuel or whatever it might be. But when we eat things, we don't immediately have to use all that energy, right? Right? We have that energy stored for later. Okay, so that's considered stored energy. Our body is able to convert that chemical energy into energy that we use for movement. Okay, but we don't have to use it right away. What are some things that do maybe affect your energy levels right away? Okay, think about just some foods or some fuel you might use that might affect your energy levels quicker than another. I want you to Caffeine, that's a good one. Yeah, that's a really good one. And what does it do to our energy levels? It goes really high and then what?
It drops.
Then drops, right? So we see this energy fluctuation. What are some other things like that?
Anything with sugar?
Bingo, right? Anything with sugar, right? So you hear like a sugar high and then a sugar crash, right? Those things have high fluctuations. So what are types of fuel for our bodies that are better than those sugars and caffeines? What other fuels for our body would be better? Proteins, vegetables, right? Those types of things help our energy levels stay a little bit more steady, right? Than these highs and lows. So that's just something to think about. All right, let's move to the next one. Electromagnetic energy. Power lines carry electromagnetic energy into your home in the form of electricity. Okay, so we see all of these things happen and compound to get to electricity. Now, we're not going to go into how electricity is made and all that kind of stuff. That's above my pay grade for sure. But all of these types of energy have been transformed and kind of tunneled into us being able to use them as electricity. Okay? Light is the form of electromagnetic energy. And then all the colors we see represent different amounts of electromagnetic energy. So when we see different colors, it has to deal with electrons and how much energy they have. And then when they fall, it emits a light and emits a light at a certain color. And so we're not going to go into a bunch of this, but different colors of light happens on different wavelengths of energy. Okay. Yeah. And then electromagnetic energy is also used in X-rays, radios, and then like laser type lights. So all of those are considered a broad spectrum of electromagnetic energy. It goes all the way from the electricity we use in our homes, all the way down to like X-rays, radios, all that kind of stuff. So that's a broad spectrum there. All right, nuclear we said is the atom. Okay, the atom is the source of nuclear energy. Because what did we say was contained within the nucleus of an atom? This should be everybody. What did we say is in the nucleus? Protons and what else? Neutrons, right? And neutron has a neutral charge. Protons have a plus charge. So those two don't automatically attract, right? Neutral and positive don't necessarily attract. Positive and negative would attract. So there's got to be something extra that holds those together, and those are called nuclear forces, okay? So when the nucleus splits, this is in high energy systems they use to make energy. Nuclear energy is released in the form of heat and light. So these are like nuclear power plant type situations, right? They're making this high pressure, high energy system so that the nucleus of atoms split and it produces energy. It also is released when two nuclei collide at high speeds. That's not something that happens like in everyday systems, right? These are, again, like power plant situations. The sun's energy is produced from nuclear fission, which is a reaction in which hydrogen nuclei form helium nuclei. So we see two hydrogens come together and form a helium. That happens in the sun, right? And again, the sun is not standard conditions, right? The sun is super high pressure, super high temperature. Okay, so we see different things happen there. All right. Oh, I took this out on your notes and I didn't take it out on mine. Most of us don't live within this power plant. I took this from somebody else. All right. Nuclear energy is the most concentrated form of energy, right? It's got really high energy levels and really high temperatures that cause like this really intense energy stuff. Okay. So nuclear power plants are intense and really high energy. All right, last part here is called mechanical energy. Okay, when work is done to an object, it acquires energy. The energy that it acquires is called mechanical energy. Okay, so that's the energy we receive as a form of some sort of transfer, right? If somebody pushes me, I've then received mechanical energy because that push, all of that energy is transferred to me, okay? You can think of it as received energy. Okay. Now, mechanical energy, like I said, is kind of the energy of motion, right? What happens when one object collides with another. When I kick a football, I'm giving mechanical energy to that football, right? I am applying a force which moves that object, right? I'm giving that object mechanical energy. Okay, this happens in all of sports, right? Think about any sport you can think of that requires like a ball or a birdie or something, right? We've got to move that object. So we either hit it, we throw it, we use a racket with it, whatever we do, but we're transferring energy to get that object to move. So sports is a really, really good, it's a really good example for us of mechanical energy and its transfers. Okay? When I throw a ball, you're giving it energy. When the bowling ball hits the pins, some of that energy is transferred to the pins, right? That's just what we were talking about. I gave the ball energy, and then the energy that's contained within that ball is then dispersed throughout those pins, and it knocks them down, right? And that's it. Okay? One form to another, those things are just called energy conversions, right? They are converted from heat to light or whatever it might be. But energy conversions are when energy is transferred from one form to another. Okay? It could be heat energy to mechanical energy or electrical to light or whatever. All of these different types of changes are called energy conversions. Okay? So this first bullet says the sun energy through solar cells can be converted directly into electricity, right? That's how solar panels work, right? That's a very broad stroke of how solar panels work, but the sun's energy is created in solar cells and then it's converted into electrical energy. Green plants convert the sun's energy into starches and sugars, which we consume, right? Which then we convert to chemical energy. So there's all sorts of things we can look at. In an electric motor, we convert electric energy into mechanical energy, right? So we take fuel or we take the electricity and we convert it into movement. In a battery, we convert chemical to electromagnetic. So battery, we take chemical energy, we make electricity. Okay, mechanical energy of a waterfall is converted to electrical energy in a generator. Have you seen that? Water-powered generators and things like that. Okay, in an automobile, fuel is burned to convert chemical energy into heat, and then we turn heat into mechanical. Okay, so we see a piston system within most engines where the steam is moving in, all that kind of stuff. There's a lot of moving parts, but we see energy transfers go all the way from the fuel to the movement. Okay, that's where we're going to stop for today.